In these last set of notes for Module 1A, we have angle bisector and angle addition postulate. So we're going to start out with the angle addition postulate. This is going to be similar to our segment addition postulate, but just dealing with angles. So in words, if point B is on the interior of angle RAD, then let's go ahead and draw that first. We know that we have an angle RAD. Remember that the middle letter A has to be our vertex. That's why my A is right there. If I know that point B is on the interior, I just need to put it in here somewhere. And then I'm going to connect a ray that goes through that as well. So the measure of angle RAD is equal to the sum of the measures of those two individual angles. So RAB and angle BAD. So using symbols, you can see that I wrote out that the measure of angle RAB plus the measure of angle BAD would equal the measure of RAD. So if you add up the pieces, it will equal the whole angle is the biggest thing you want to remember. So when we are looking at this picture right here and we want to find what is the angle QRT, we need to combine the two individual angles together and that will give us the full angle. So just to start out, we're going to write out just what the names of those angles are going to be. So we have angle QRS plus angle SRT is going to equal then our full angle QRT. And then we can substitute our values into each of those places. So our QRS angle is 15, the SRT angle is 30 degrees, and then that would give us the measure of angle QRT. And that would be 45 degrees. Now with some more algebra, instead of just the degree symbols in there, we're going to do basically the same exact thing, and it tells us in this one that LKN, so it's always nice to kind of follow the letters as I say them, that whole angle is already going to be 145 degrees. But we need to work backwards and solve for x. But remember, let's set up an equation like this with words and symbols in there instead. Then we will substitute the parts in blue in place of each of those pieces. All right, so that's what I've got. So LKM is our 2x plus 10. The measure, or the angle MKN is 4x minus 3. And they told us that the measure of angle LKN is 145 degrees. Now it just comes down to solving for x. And in this one, we just need to solve for x. We won't have to substitute it back in. So let's combine our like terms together. We've got 6x's all together. The positive 10 minus 3 is a plus 7. Equals 145 degrees. We have to subtract the 7 over. I can't show that step since that's a little more space than I'm going to need. That would make it 138. If I divide both sides by 6, we would get 138 divided by 6 is 23. So x will equal 23 in this problem. We've seen the word congruent before. We know that congruent means that they have the same measure. So if we have congruent angles, that means that we have two angles that have the same measure. Now for an angle bisector, we know that bi means it connects it into two. So this means it bisects it, means that it cuts it into two pieces or two sections. So an angle bisector is a ray that divides an angle into two congruent angles. And instead of the word congruent, you can always put the symbol for congruent instead. So congruent angles have equal measures. So keep that in mind when you're solving these out. All right, so with angle measures in our diagram at the right, the ray YW, which is right here down the middle, bisects angle XYZ. So remember, bisects means it cuts it into two equal pieces, or two pieces, and then they are going to be equal. So if we know that the angle measure of XYW is 18 degrees, and we know that they have to be congruent to each other, that's what these little red marks in there are showing us, then we know that the other angle also needs to be 18 degrees. So when they need us to find X, Y, Z, that's the whole thing, we just need to combine those two angles together. And 18 plus 18 is 36 degrees. Now realize that was just with numbers, and we're going to do it now with some algebra in our problem as well. So in our diagram now, we have that the ray BD bisects our angle ABC. So that tells us these two angles are congruent to each other. We show that they're congruent by putting those little arcs right there. And then we need to find the angle ABC. So not only do we have to solve for the x, but we're going to have to substitute it back in to figure out what those values will be. Because they are congruent to each other, that means we can set them equal. So don't ever forget that part. So we need to set our two pieces equal to each other. And that would be 3x plus 17 equals 7x minus 39. Now we need to move our x's so they're on the same side. So if I move my 3x over, that would give me a 17 now on the left, and subtract it would give us a 4x minus 39 left over on that side. I would need to then move my 39 by adding it to the other side, and that would give us a 56 equals our 4x. Divide both sides by 4. And we get x equals 14. But now remember, they're not asking us what the measure of x is going to be. We need to substitute it back in. So we would have 3 times 14 plus 17 for this first angle. And that gives us 59 degrees. So this left angle is 59 degrees. Now if you think about it, the other one should be the exact same because they are congruent. So if we need to find the angle of ABC, that's all of them together. So add those two together and we get 118 degrees. Remember, for your final answer, always write it fully out. So you'd have the measure of angle ABC is equal to 118 degrees. All right, so for this next one is kind of your turn to do sort of the same thing. That I want you to now work this one out and read the directions for the ending part as well. All right, so this first step, you get 5x plus 16 equals 8x minus 23 because they're congruent to each other, so you'd set them equal. Then if you move your x's over, you would have a 3x over here. If you move your 23 to the left, you'd have 39 equals 3x, then divide by the 3, and when you get x equals 13. When you plug it back in, you'd have to take your 5 times the 13 plus 16, and you end up with 81. So if this angle is 81, the right one would also have to be 81. Together would be 162. Linear pair is also going to be a big vocab word you're going to see throughout the school year, and that means we have two adjacent and supplementary angles. So for a linear pair, their non-common sides, the sides they do not share, form an opposite ray. Now my two pictures down below show one of them is a linear pair, the other one is not a linear pair. So they need to be adjacent, which means that they need to be sharing a side. And if you notice for this one on the right, they do not share a side. Since they do not share a side, then they are not able to be a linear pair. They are supplementary because supplementary means that they equal 180 degrees and we have 110 plus 70. So they are supplementary, but since they are not adjacent, they cannot be a linear pair. The example on the right shows that they are, or sorry, on the left, shows that they are adjacent because they share this side in common, they share the vertex, and they are supplementary even though we cannot see what the degree measures are because this makes a straight angle. And we know that a straight angle together means that it is 180 degrees. So we can see that this is adjacent, it is supplementary. So this one is our example of the linear pair. For this next example, we have with angle measures. So if angle 1 is 82 degrees, then we need to figure out what the angle 2 is going to be. Now realize this is a linear pair, and if it's a linear pair, we know that it's adjacent. We also know it's supplementary. So we can use the idea that all together these will equal 180 degrees, which means that we can add 82 plus angle 2 equals 180 degrees, and then we can solve for the measure of angle 2 by subtracting 82 from the left, and we would end up with 98 degrees for angle 2. All right, for letter A, we have the exact same picture except we just know that we need to solve for x. But again, this is a linear pair and they are supplementary, so together they equal 180 degrees. So we can say that 5x plus x equals 180 degrees and use that to solve for x. So we can combine our like terms, so we get 6x equals 180, divide both sides by 6, and we get x equals 30, and in this problem, that is all we need to find. On letter B, I want you now to do the exact same thing and set it up to solve for x. This is similar to another one we saw before, so if we combine our like terms, we get 14x, plus if you add your 9 and your 17 together, you get 26. Then to solve for your x, you subtract your 26 over, and you get 14x equals 154. Sorry about that, that's supposed to be a 4. And then divide by 14, so we get x equals 11. And I'm going a little faster on these. We just want to use these as some more additional examples so you can see some different variety questions. So if you ever come across any of these in your assignments, you can always pull this back up and see how we wrote out what the setup was going to be. On letter C, we can see that we have a couple of different options. We have vertical angles right here, which we know vertical angles are going to be congruent to each other. But if you look at it, if we set 7y plus 5 equal to 9x plus 2, we have an x and a y in the same problem. That we cannot do anything with. If we look at these two with the x's, we want to set up some kind of equation with just using these two angles. And we see that this is a straight angle, so together would be 180 degrees. On this one, it doesn't ask us to solve for the y, but we could ask you to solve for the y as well by setting these equal to each other. But you'd have to find the x value first before you could do that. On letter C then is going to be the exact same setup you just saw. You can add them up to equal 180. Then when you go through and solve it, you would end up with x equals 5. So I'm not going to show the work of all of that one. I just want you to write down the setup at least and then get your final answer. So you can always go back and check this later if you would like to. On letter D, now this is an important one because these are vertical angles and that means that they are congruent to each other. Remember, if they are congruent angles, we can set them equal to each other. So 9y plus 7 equals 2y plus 98. And then you can go through and solve that. And on this one, again, we've set some up like that before, and on a lot of these, it's just the setup that I want to focus on, of knowing what your properties mean and how you can use that to set up your problems. On letter E, we see that there is 90 degrees on this right side of our problem, which means, since this is a straight angle, that means that these two angles together will equal 90 degrees as well. So these are complementary angles. If we then set up 5x minus 4 plus the 11x minus 2, if we add these two angles together, that would equal 90 degrees, not 180, but 90 degrees. Now let's go ahead and solve this one. We can combine our like terms together. We get 16x minus 4 and a minus 2. We get a minus 6. Add your 6 over, and we would have a 96 equals 16. Divide by 16, and we would get x equals 6 for this last one.